Okay, so today is Tuesday. We're going to talk about parallelograms, and your homework tonight should be fairly simple, straightforward. Again, I'm not going to require you to memorize what the parallelogram theorems are as far as being able to regurgitate them by hand, but you need to know what they do. So let's look at two of them real quickly. Parallelogram opposite sides theorem says that the opposite sides of a parallelogram, if you know they're a parallelogram, okay, first of all, you have to know it's a parallelogram. Then you know the opposite sides are equal. So as you see in our picture here, QR is the same length as PS. That's the opposite side. And the other opposite sides, PQ and RS, those are the same distances. All right. Then opposite angles theorem says that in a parallelogram, again, you have to know that it's a parallelogram, then the opposite angles are the same angles. So if this was 70 degrees, then angle R would be 70 degrees. Okay? And same thing with Q and S. If we knew what those angles were, they would be the same from Q to S. So if we said 110 degrees, then Q would be 110 degrees. That's what those two theorems mean. So we'll go to the next slide. And on these two, we have the consecutive angles theorem. So not only is Q and S, RQ and S the same, and P and R the same, but if this is a parallelogram, we have two parallel lines cut by a transversal, and X and Y are consecutive interior angles. So x plus y is equal to 180 degrees. And the same if we go the other direction. You have two parallel lines cut by a transversal, and x and y here are consecutive interior angles. So you have consecutive interior angles in all directions. So they add up to 180 degrees. All right, and then the one below it, diagonals theorem. If you know you have a parallelogram, then the diagonals bisect each other. So PR is bisected into two equal segments, and QS is bisected into equal segments. So those are the two theorems. Let's take a look at some of the homework problems. So on number 4, it tells us right away that we have a parallelogram. So I know that N is the same as 12. But then what is M, as in Mickey, or excuse me, Mike? M plus 1 is equal to the 6. So then you solve that, and M is equal to 5. So N as in Nancy is 12, M as in Mike is 5. All right, and then we look at number 6, and we have two different types of things here. We have opposite sides, and those are equal, and you would have to try to figure that out. So 16 minus h is equal to 7. And now we have to solve for h. If I subtract 16, I still have a minus h on the left, but that gives me a negative 9 on the right. So a positive h is a positive 9. And then I have angles on the inside, g plus 4. That's equal to 65. They aren't consecutive, so they're diagonal from each other, and they're equal. So you have g plus 4 is equal to 65, and you subtract 4, and g is equal to 61. Okay, so h is 9 and g is 61. All right, so that's using those two types of parallelogram theorems. Let's go down to the next one. Find the measure of the indicated angle in the parallelogram. Angle N. Okay, so M and N are consecutive interior angles because it tells us we have a parallelogram. So consecutive interior angles add up to 180. So 180 minus 95 is 85. So angle N is 85 degrees. All right. So now we have 9 through 16 here. We have the parallelogram symbol in front of L, M, and Q. So we know it's a parallelogram. Find the indicated measures. So this is kind of like a puzzle. We'll get back into puzzles again here. LP, number 10. We'll just go through some of these evens. LP is just this segment here. Well, remember, in a parallelogram, the diagonals bisect each other. So LP must be the same as PN. So LP is equal to 7. Go to number 12, MQ. MQ is the whole length here, MQ. So we know M to P is 8.2, and so PQ must be 8.2. So we add those together to get the whole thing, and MQ is 16.4. All right, now explain your reasoning, don't worry about it. That's just naming the parallelogram. You should know the names, I'm telling you that. I told you how to do it last chapter. That's up to you if you do it. You will have to know the names at some point in time. All right, but you will not have to write out the definitions of them. I'm not going to do that. So number 14 is angle NQL. NQL. So the whole angle there. I'm going to erase some of the stuff that I've already marked. All right. And now NQL is this angle right here. It's not 29 degrees. All right. So what we need to look at is that we have two parallel lines cut by a transversal, and that the 100 degrees that we have there and the blue angle that I marked there, those are consecutive interior angles. So that means that must be 80 degrees. All right, that's 80 degrees for this blue or yellow angle now that I've just marked. All right, I'll erase that, and we'll go from there to the next problem. And the next problem is number 16, LMQ. LMQ is this little angle right here. All right, so again, I'm going to point out something here. I have two parallel lines cut by this transversal. These are alternate interior angles, 29 degrees and that angle that we're looking for. So that is 29 degrees. Alternate interior angles are equal. Number 18, find the value of each variable in the parallelogram. All right, so now you need to know that consecutive interior angles are the same, or not the same, they add up to 180. You also have angles that are diagonal from each other. Those are equal. So I'm just going to write these down. C, oops, I'll do it in black. C equals B minus 10. But that's two variables. We can't solve that. What about the other side? Well, here we have D equals B plus 10. Well, we can't solve that because that's two variables. Well, let's take a look at consecutive interior angles that have the same variable. All right, so I can write down that B minus 10 plus the B plus 10, those are consecutive interior angles, they add up to 180. So that's why I'm adding them. Consecutive interior angles add up to 180, consecutive meaning right next to each other. So the negative 10 and the positive 10 are on the same side of the equal sign. They just cancel each other out. So I have a B plus another B, that is 2B equals 180. Divide off the 2, and B is now 90. And all I have to do is substitute that back into these two equations for B, and that'll give me C and D. All right, number 20, these are diagonals that in a parallelogram that bisect each other. So 2u plus 2 must be equal to 5u minus 10. 2u plus 2 is equal to 5u minus 10. And then you just solve that algebraically. The same thing with the other one. I'll do it in red. The 6 is equal to the v over 3. 6 equals v over 3. And you solve it algebraically. Multiply by 3, v is equal to 18. All right, so basically, let's take a look. I'm going to blow up this side a little bit here and just say you got a proof on number 23. Make sure you have your theorems out in front of you. And then you also have these coordinate things you need to draw and try to answer the question that they're asking. You'll need distances and midpoints. So we're going to do, the homework assignment is going to be, whoops, let's go back here. Page 372, and you're going to do 3 through 29 odds. Okay? Do not just write things down. Try to write as much work as you can. Make sure you're doing that, and it's due tomorrow by 2:30. If you have more questions today, yesterday's assignment's due by 2:30 today. I will take questions from that later on in class in just a few minutes if you have any, and also over this as well. From 1:30 to 2:30, we have office hours. So if you have questions, you can email me and I'll answer those. And that way the emails come together. If there are a lot of the same questions, I can answer them all at the same time. And I'll send out a little video explaining certain things if you have those types of questions. So email me questions if you have questions from 1:30 to 2:40. All right, I'll see you in just a few minutes.